So in this session, we'll be covering specifically the use cases in healthcare, which comes from NLP. So NLP basically is natural language processing. Natural language processing means the language which we as a human beings have. So normally how we basically do communicate, think, write. So that's using a language. The language could be English, Hindi, Marathi, Gujarati, Kannada, whatever. So these are different languages which we basically make use of, and using these languages, we are able to do all the general stuff and all the professional stuff and all the chit chatting, all the social, everything is done with the help of NLP. So natural languages in case of computers are basically human languages. Now, a computer getting ability to deal with the natural language, so that's a challenging task. Like that's something very interesting, challenging task. But we see today as a consumer of technology and AI ML based devices that we do really see that computer is very well able to understand is very well able to understand the language, the grammar, the context, and it generates results very interestingly, which is to a great extent accurate most of the times. That is what we are able to see. Now, this particular concept of natural language processing is impacting almost all the industries. So we will be coming specifically towards the healthcare domain. All right, so I have listed down some of the use cases over here. So first is clinical documentation. The problem is manual documentation is time consuming for healthcare providers. So the solution is NLP can automate the extraction of critical information from clinical notes, allowing the doctors and nurses to spend less on paperwork and more time with patients. So that's the automatic summarization of clinical notes and generation of structured report. So this is again very experimental, but it is a good use case which with high accuracy can be really helpful. Second is medical coding and billing. The problem here is translating physician's note into medical codes for billing is prone to errors and inefficiencies. So NLP models can automatically extract billing relevant information from client notes and and can assign the correct ICD or CPT codes. So if you are from healthcare pharma domain, so you must have had a subject on ICD and CPT, where basically with human error it might lead to a lot of errors, inefficiencies, and productivity losses. But if we are using NLP models, they are more faster, they are never tired, and they are more accurate, and they do not have the kind of humans get tired and emotions are there, so they don't have it, so they can mechanically work and perfectly bring out the data. Next we have is improving accuracy, reducing the denials as well. Then example is automating the medical billing process by linking symptoms, diagnosis, and treatment with right codes. That's something we can do. Then next is very important, like which whenever I had to visit hospitals, and sometimes when I got a chance to very closely, understand the psychology of patients. So that's very important. To like many a times, it's not just medication. I mean, almost all the times, it is something how the patients are feeling over there. So that's another important thing. So the problem is analyzing large volume of patient feedback that can be difficult for healthcare providers. So in a very big hospital of maybe 600 plus 1000 plus beds, so it is very difficult to take care or personally take care of each and every patient, and to understand how the treatment is being given, how they are being handled. So there also the solution is NLP can perform sentiment analysis on patient feedback or surveys to identify patient satisfaction level and highlight areas needing improvement, understand patient emotions better, identifying recurring complaints or sentiment across different feedback platforms. Then speech recognition for voice powered applications. So the problem is typing clinical notes can slow down the documentation process. So here NLP based speech recognition system can transcribe spoken language into text, helping doctors, nurses dictate their notes instead of typing them. So that's the benefit we can get over here. The example is like Dragon Medical One, a voice recognition tool which is used by physicians to transcribe notes directly into EHR, electronic health record. That's one example. Then clinical support systems. So clinical decision support systems. So the problem here is healthcare professionals often need quick access to medical knowledge and guidelines. That's very common thing in all the departments we see. So the solution is NLP can assist in retrieving relevant clinical guidelines, research articles, or past patient cases by understanding the natural language queries of healthcare providers. That's something as a benefit we can get. Here examples are a doctor could query recommended antibiotics for 10-year-old with bacterial pneumonia, and an NLP powered system would retrieve relevant guidelines or research. Next, adverse event detection. Adverse events basically mean that, for example, drug reactions or complications. So they are not always explicitly documented. So specifically, those who are little less experienced, or even with experienced ones, specifically, for example, like COVID situation, so many experiments had to be done, and so many, I'll say, experience based, assumption based, and real time observation based medications has to be prescribed so that the patients can be treated well and lives could be saved. So these are some adverse events which basically can be a challenge. But here also NLP algorithms can analyze the unstructured text in medical records to identify mention of adverse events or complications that may be otherwise missed. So that's something is the application area of NLP again, detecting mentions of medication side effects or surgical complications in patient records. Another use case we have is patient risk stratification. So here, the problem is identifying high risk patient can be identifying high risk patient can be challenging when medical data is spread across various records. Now again, NLP can analyze unstructured patient data such as history, symptoms, or previous notes to identify high risk individuals for conditions like heart disease, diabetes, or the readmission risk. Readmission risk. Yeah. So here, predicting which patient are at high risk of developing sepsis based on clinical notes and lab data. So that's what NLP can help. Then clinical trial matching. So the problem statement here is it can be difficult for patient and clinicians to find relevant clinical trials. The solution is NLP can match patient profiles with ongoing clinical trials by analyzing patient health records and trial eligibility area criteria. So automating the process of identifying which clinical trials, which clinical trials a cancer patient is eligible for based on their medical history. So that's something can be done. Then pharmacovigilance, that's another. The problem area is monitoring drug safety and identifying adverse drug reactions, ADRs, is critical but challenging with large volume of medical data. Here again, NLP can help. So NLP can analyze patient reports, social media, and clinical notes to detect potential adverse drug reactions and report them for pharmacovigilance. Example, detecting emerging drug side effects from online patient forums or EHRs. The last use case I have listed is patient-generated health data, and a lot of valuable health information comes from patient interaction on forums, apps, wearable devices, which is hard to analyze. So here also NLP can help. So NLP can analyze the patient-generated health data, such as symptoms described in patient forums, to provide insight into population health trends, patient behavior, and unmet needs. Example, analyzing conversation in online support groups to understand patient concerns about chronic conditions. Talk about some use cases with the help of Python. So let us walk through Python-based NLP use cases in healthcare for clinical entity extraction from unstructured clinical notes. This can help in identifying key medical entities such as diseases, medications, symptoms, and treatments. From free text doctor notes, we'll use SparSci, a popular NLP library, to extract these entities. So yes, so let us basically start working on it. So this is the environment which we will use, that is collab.research.google.com, and I'm sharing that with you here on the chat box as well. So you can see I have shared. You can open this particular link. You need to be logged in into Gmail for utilizing this. So yes, so I am working on this particular area. So I'll just rename my notebook. So here I have renamed. Yes. So, yes. So in Python, we always need to install a particular library before we actually can use it. So pip install spa-sci. So I'll just install it. Pip -tll install spa spa-sci. Okay. So this particular. So you'll need to install spa-sci, SPACI, and a pre-trained NLP model. So there is something called as pre-trained. Pre-trained means that NLP models need to be trained. That means we need to give them some data so that they can learn from the data. Pre-trained is means we have already trained or somebody else has already trained them and we can now use them. So that's a reusability thing that support clinical and medical terms. Okay, so that basically we need to do. So it says that requirement already satisfied, which means that this library or package is already there. Then Psi SPA-Sci. So this is for biomedical models. So pip install Psi SPA-Sci. This is also I'm going to install. Pip install Psi SPACY Psi SPA-Sci. Okay, let it get installed. Then after that, uh, yes, I'll bring this. Yeah, so you can say preparing metadata, collecting. So most of the things are already installed. Okay, fine. Building wheels. So it is doing that. This is an alternative if that doesn't happen. We'll just see. Once it is done, this will get installed. Now moving to the step two. So this was step one, and let me just put it by the time it is happening. So I'll just put it as a text over here, and it's step one. Okay, then yeah, so it's still happening. Building wheels for collected packages, no problem. I'll add a text area over here and there. So import required libraries. That's the step number two. That's the step number two we need to do. So import the required libraries and yeah, meanwhile I can do this. So import spa-sci, import import SPACY spa-sci, and then load the SPA-Sci clinical model for entity recognition in medical text. So we have en underscore core underscore sci underscore md. This is a model basically here. So I'll be using this particular model. So let me take this piece of code, put it over here, and still it's still working. Okay, so till that time we will do a code walkthrough. So this, and then step number three is sample clinical data node. And so that we actually need sample clinical data node. So I will add code area. I'm not executing these particular things because uh, uh, once the execution at the previous step gets completed, then I can start executing. So here clinical note we need to make. So this is a clinical note which has been made inside only inside the Python only. Okay. So then next is process the clinical text. So let me take this, so how it can be processed. So next is process the clinical text, and then use SciPy NLP pipeline to process the clinical note, extract entities. So process clinical note text with SPA-Sci pipeline. Doc is equal to NLP clinical note. This is the piece of code we have written. Now extract medical entities out of it. Step number five is extract medical entities out of it. So here you can see extracting the medical entities from it. So after processing text, the doc object will contain the entities identified by model. We'll extract entities of interest such as disease, symptoms, medications. So we are calling them as entities over here. Now, what next we will do? So we can expect some output like this: entity 65-year-old, label age, then here entity type 2 diabetes, label disease, entity hypertension, label disease, hyper lipidemia, so label disease, chest pain symptom, shortness of breath symptom. Okay, so this kind of entities we will get. So now let us go back and check if these processings are over. So it was taking a lot of time. So yeah, successfully downloaded. And this I'll just comment because already we have downloaded in the previous step. So now I'm importing SparseI, you can see, and sample clinical data node I have created. So after loading, so I have loaded the model also. So now it says can't find model. This model is, it's not able to find this particular model. So as of now, like to become very quick, what I will do is I'll be taking help from ChatGPT, whether it is so it can suggest me some other model. Okay, so I just yes, pass this error. Yeah. Okay, so to resolve this, you can install model by running this command. So it is asking me to run this particular command, and after this, I should be able to. So let me just try doing this. Okay, so it gave me this option, but it was giving me some error for it, but no problem. So is it exactly same? It seems to be exactly same. So let me just try doing it. Wow, it's doing, yeah. So it's downloading that particular model. So it's a pre-trained model which we are downloading. So after this, we should be able to run. So whenever you need help, you can quickly take help from uh, ChatGPT is not professionally much recommended that way, but if you want to practice and gain knowledge, I believe you can use it. And otherwise, you can go for a paid version of ChatGPT. That is how you can work. Okay, great. So once it will be done, we'll move ahead and we'll execute this particular import SparseI, which is going to help us. So load the SparseI clinical model for entity recognition in medical text. So the benefit we get from Python is that we have so many packages for healthcare, medical, so many packages are there. The following packages were okay. Click okay. You must restart the runtime. No problem. I can restarting will lose. So if I restart the runtime, okay. And now if I move ahead, yeah, okay, yeah, fine, fine. So I just need to do it. Okay, okay. So yes, so with NLP, so NLP, did we create NLP? Yeah, so here we create NLP is equal to sparsi.load. So here we have created that thing. So NLP is equal, doc is equal to NLP clinical note. So it should give me, bring the clinical notes, and then we should be able to print them here. So that's something we want to do. Like we first want to get that extracted data. Let us wait for it to get executed. Yes, so you can see that here we have entity, patient, label entity, entity mail, label entity. So all of these, okay, so here label is coming as, okay, for all of them, it is coming as entity only in our case. Okay, fine. So let's go back here. So labels are not coming this way. Labels are coming as entity only in our case. Okay. So in this case, if I am going to create groups, so groups are going to create, there'll be only one group in this particular case. So yes, so it won't be like this. It will be, so in our case, it is not like, it is simply, so I'll just go and check here. So NLP clinical note, and so here doc doc1 is equal to NLP, and so I would like to um, hmm, Fine, it is giving me some suggestion, no problem. And from doc1 also I'll try to get the same. Okay, so yes, so for ENT in doc1. So I would like to get like how it is identifying the entities. Print slash n doc1 slash n. Okay, so it's getting everything as entity only. So ent dot label. Okay, no problem. So I would also like to get, so print ent dot, not start character, anything. So just label also I would like to get. So okay, it gives some number. Okay, fine. It's giving some number here. So in our case, it is not going to like it's not giving any uh, different label. So that also I can ask to ChatGPT. So I can share this. Okay, so it might have changed something. So I am not uh, getting the ENTITIES entities as DISEASE disease, SYMPTOM symptom, or medication, MEDICA medication. Okay, so let me just see. Okay, so if the issue you are facing is that default entity labels are generic, that is entity, which is likely you are seeing this. Okay, that's the reason why we are seeing this. So okay, which is likely, okay, improve this. Use, okay, we'll have to use another model for it. Yes, so SciSPA provides model trained for specific tasks such as detecting medical terms, more granular entity levels. You can use more specialized SciSPA model like en underscore ner underscore bc5 cdr dot underscore md. So for diseases and chemicals, or this one. So this I will use. So let me use this one. So I'm changing the model now. So I'll go back to uh, yeah, this place, and so we are able to identify the entity, but we are not able to identify the way we actually want it. So therefore I'm changing the model, and we'll be using this new model now. Okay, so yes, so let me copy this piece of code, and we'll be using, okay, okay, yeah, it's building. Let it build. Then okay, done. So here let me just load it and then process the text. So the text processing should happen here with this model. Uh, okay. I should have given it as NLP 1. Okay, so I'll just give it a new name so that, so here also it is NLP 1. Okay, because I just don't want it to get mixed with uh, the old names. Now let's extract the entities. And this also I would like to make doc2 and extract. So extract here. print slash n doc. Okay, fine, nice. Incomplete input. Okay, I'll complete. No problem. I'll do complete it. Uh, where is it? Yes. Okay. Yeah. Now we have got. You can see. Now we have got chemical disease. Okay. So that's nice. So yes. So doc two is now. I hope everything is clear. So I have changed the. Here you can see what I did. I have taken a new model. So we need to see that which model we need to use in order to work on these things. So I have used a new model here. And now let me, hmm. So we're working on doc 2. So doc 2 is something we are working on. And entities is equal to, so we have, so you can see the labels which we have. So it's more ENT. Okay. Dot label. So what labels we have? Mm, no, here, comma. We have disease is done. Chemical is one more. CHEMICAL. Chemical is another. Colon. Okay. Anything else? So disease and chemical only. Uh, yes. Okay, it didn't print it. Okay. Yeah. I'm sorry. So print chemicals. Yeah. Fine. So you can see for chemicals also we have. So we have groups available here. Okay. So yes, custom pipelines. Hmm, correct. So we are able to find this. Okay. Now let us go back and here. So we have got this kind of. So store or use extracted information. So we can store it in some file, JSON file or something. Okay. So this is like finally if you want we can store these into text file or JSON file, so that I'm not doing that. But here we can see that this is a kind of help which this is a kind of output which we get. So this is one use case which I have shared with you on healthcare. Okay, that is finding out the entities. Now I'll bring another use case, and you can make use of ChatGPT for these things because you are non-programmers, so you can do. And once you have made use of it, then secure your code like whatever Python code you're using. Now another thing is, I'll help you with create a CHAT chatbot for ICD and CPT, medical coding coding. Okay, give STP step by step code in Python. Okay, so another use case. Okay, this probably can be a mini project for your, if you are doing some academic research or project. So this can be a mini project you can do. So yeah, let's discuss on this, how this can be worked upon. So to create a chatbot for ICD, that is International Classification of Disease, or CPT, that is current procedural terminology, medical coding using Python, we'll use the following steps. So the step number one is that set up the environment. So let me take this. Okay, we can do it from here also, no problem. So install the necessary package like SparseI, Rasa for chatbot framework. So SparseI already we did. Rasa we will take it. Okay, and any specific libraries for ICD or CPT codes. So we need to have use a dataset containing ICD CPT codes for lookup. Now, train a natural language understanding model. So in NLP, there is one part is natural language understanding, and there is another part natural language processing. So step number one is natural language understanding. Step number two is natural language processing. So two steps are there. So we'll use RASA NLU for intent recognition and entity extraction. So this particular package, the chatbot needs to recognize medical coding request and extract entities like symptoms, diagnosis, or procedures. Then design the conversation flow. Define how the bot should interact with user, ask for clarification, and provide medical codes based on user's input. Then code the bot logic. Yeah, once the bot recognizes the user's intent, it should query ICD CPT dataset and return the relevant codes. So now let us do step by step. So step number one is setting up the Python environment. So I'll be making a new notebook here, new notebook, and we'll do it in a new notebook because this is good. Like we have done it one sense over here. So in this particular new notebook, the step number one is set up the Python environment and install the necessary dependencies. So let me add a text area over here, and in the text area, okay, hash, and yeah. So now here so we are installing a couple of libraries. So Rasa, Spasai, and we need to download this Encore WebMD. So these three things we need. Let it get executed. Then second is yes, so we need to get this particular, so create a data set. For simplicity, we assume you have a CSV file. So I need to get such kind of a CSV. Let me check if I can get it quickly. So MEDICL medical codes, so CODS codes, CSV, yeah, CPT code CSV. Excel, very good. CPT codes, here you can see I may get it. So that's a wonderful thing I'll be getting. So create a data set for ICD. This is step number two. So we'll go step by step. It gives me an error, so I can just bring the pipes, the symbol over here, and let me get that executed. And then here also I'll get this. Okay, fine, it's working. Yeah, so now let me have a text area over here. So creating the data set. So let me find here. Okay, wow, cpt4.csv. It has got one, two, only two columns, and it suggested type. Acha, type. So we don't need the type. Okay. This is coming from CPT only, right? So I will get a raw and I'll save this particular file. So CPT4 file I've saved, and then uh, I will get ICD. So sorry about that. No, you can show me raw. I have no problem. ICD10 CSV heads. Okay, I think this may be fine. Okay, so yeah. Yes, so let me save this. And yeah, so now I need to tell, yeah, rest things we will do later, but I need to tell it that I have these two files, this one and this one. Please update the COD code ACCORDINGLY accordingly. Okay, so I've shared. So let's update. Uh, so, hmm, uh, so categories presuming containing ICD codes. Yeah. Fine. So I'll get the data in this particular manner. Okay. Mm, hmm. So copy this particular code and let me come over here. No, I will not restart because restart, will I'll just put it over here and I'll upload those two files. So one and two, both the files I'll upload them here. And okay, after uploading them here, I'll just copy the path and I'll put the path over this particular place. So this is which one? Control V, categories, yeah. And this I will copy and I'll be putting it over here. Control V, okay, fine. And then I'll be executing this. Okay, so yeah, so we'll read the files using pandas that we have done here. And okay, so load the files, adapt the queries. Okay, bot responses, update the data frames, run the chatbot. Okay, so hmm, so let me just try with this. Okay, invalid syntax. So probably this is not. Hmm. Okay, so now they have updated this, and let me go back here. So, hmm, we need to do some updates. So, yeah, set up the Python environment. This is done. Okay, set up the Python environment, and then this part is done. Create a Rasa project structure. Okay, so Rasa init, and I'll just copy this particular code, and this is step number 3, which we need to do after this. Mm, okay, it has got a little mixed up, no problem. So, okay, before these commands, I'll do. Who's running these commands here? Okay, and code over here. So, Rasa init, and yeah, so we'll see if it is doing something over here. So, it should. Welcome to Rasa. To get started quickly, an initial project will create. Need some help now. So warning, your terminal does not support cursor position requests. Acha. So. Hmm. Yes. So sometimes, this is Google Colab. So I'm just trying if it gives a solution. Otherwise, I'll have to use uh, a local platform, or I'll have to use some other operating system. So that can be a case. So I'm just waiting for this to get executed. It's giving warning, but not moving ahead. So meanwhile, I'll just make a start here for one of the virtual machine. Yeah, so I'm making a start of it. This version, and here also I'm not able to see anything happening. Okay, so this is my OS where I can try setting up installation and all. I can try doing it here. Okay. So, yes, so create the Rasa project structure, and this will generate NLU.yml, stories.yml, actions.py, then define the intents. So, this is how I need to decide the intent, then define the stories, conversation flow in the stories. This is how. Then create custom actions for code lookup. So, actions.py. So, this already is done. So, and then domain also I'll have to update this. Then train and other things I need to run. So, mhm, Google Colab. Let me ask it, can I run in Google Colab? Yes, you can. So, but there are a few limitations workaround should be aware of. Hmm. Yeah, so in Colab I'll need to do it like this. Okay. So that's what I was thinking. That's why it's not, working in a very well manner. So no problem. Like there's nothing like an issue to us. So because I have this another environment where I would like to work with it. So in this environment, I'll be working. Okay, so I'll show you that how does it work here. Now, are you in an AG running um, Jupyter Lab in Ubuntu Ubuntu? Give me the step-by-step codes. Okay, AGA again. Okay, CONSI considering the two CSV files I shared as input. Okay, so for that I would like to bring it. That's what I would like to bring. So here I would hmm, storage. I would just go to settings and I would try to increase some disk storage for it and probably RAM as well. So those two things I would try. Okay, already 4 GB is there. Hard disk is 40 GB. So yeah, so virtual machine needs to be powered off for it. I understand that. So cancel and I'll go here. I'll power it off. So these are virtual machines like in one operating system. we can run more operating systems, more than one. So that's what I'm doing here. So I'll just increase the size of this disk so that we have enough space. So expand to 45. Only 5 I will do. Okay, thank you. Okay, so let's get into it. Yeah, it's getting started. So we'll be following this. So here also we'll have to install dependencies first, then we can work. Oh, no problem. Okay, meanwhile it is starting. Yeah. So let's take it may take 1 minute's time to get started. Okay, so let me start this particular machine. It still says, hmm, okay, why I don't know. And let me get this piece. Okay, if it is shareable, I'll just get it from here. Copy link. Okay, yeah, copied. And I'll try to get it over there. POSIT posit. So yes. And here you can see some lab session is going on. So I can quit this session, quit, and I can have a new session, Jupyter Lab, start session. And here, yeah. So if I can get it here, nothing good like that. So yes, so I'm getting it here, and let me bring it as a separate. Okay, starting session. Okay, continue this conversation. Stay logged out. Okay, yeah. So from here, so we'll start. And okay, session is yet to start. I'm waiting for the session to get started. Okay, it has started. Nice. Hmm. So one notebook. Yes. So one notebook. I would like to get it here. Or rather, like I should choose this, discard. I should get a folder created, and this will be our NLP, HEALTH healthcare. So inside this folder, I would like to get things created. Yes, so that our things are separately okay dealt with. So let us install the Spasi and yes, so it's installing and then the CSV file. So we will need to have the CSV files. So for that, uh, I need to go here and I need to get this. Uh, yeah, so I need to get this here, enter. This is one file, categories. So under downloads, it will get downloaded, and then I will need it. Okay, and then I'll need the other one as well. So other one we'll take it from here, and yes. So this one, let us put it over here and download this file as well. So I have downloaded this file also. So both I have downloaded because now we'll be requiring them. So load the CSV file. I'm taking this piece of code and here we can check. So all of them have got successfully downloaded and I'm putting the code over here. What I'll do is I will try to get a new launcher. I'll try to get the files here only. Okay, so this one as well as this one, I'll get these two files here only. Okay, it says permission denied. Okay, is it? Okay, fine. So I have these two files here, and so uh, yeah, categories.csv because they're in the same place, so I need not to do anything. They're here. So let's just check whether they are getting loaded properly or not. We'll just check onto them. So yes, both the files have got loaded properly. Yes, they are loaded. Yes, that's good. That's good. Okay, so they are loaded. Okay, so they are loaded. Now, the next step. So we have loaded the CSV files, define the medical coding bot functions. So yeah, I'm defining the medical coding bot functions here. This is the class and the functions inside it. So that I have defined and then yes, initialize the bot. So I'm initializing the bot here. So bot is equal to medical coding bot, user input and response. Okay, so it gives me some error and description. The error is the error description. It did not find description. Okay, okay. So I'll just check on it why it did not find description. So yeah, let us just complete this and then I'll make the corrections. Okay, so this exit exit as of now. Okay. So here I okay. So let's go to the very initial stages of it. Very initial stages where we started. Yes. So it asked us to do certain things. Um, yeah, these commands. So we'll try these commands as well. So that description, where is that description? I'm not able to see where is that description. No problem. So I will just get it from GPT only because we do not have much time now. So I'll just get it from GPT only. Yes. So this error. So let's see. Okay, in the initial stages, if we see here, okay, code type and description. It is written this way, so it did not find the description that way. Okay. Hmm. I'll just ask it to update. Okay, so chat GPT only. Hmm. So, uh, give me PyTeacher and Python code. Okay, to keep the keep the input data as input data columns columns as code type description the index 0 column is code. Okay, index 0 1 2 2 column is descrip description and and add add ICD for CATEGORIS categories file and CPT for the other file. The other is CPT4 CPT4.csv file. Okay, and categories.csv. Okay, so let us get this piece of code. Let me check this. So yeah, here only I will check this particular thing. So just remove this and yes. So yeah, remove this and ICD codes we have already loaded. So remove this as well. ICD formatted CPT codes. So that also we have already loaded. Okay. So now let's execute this. Okay. Simple positional is out of bound. What happened? Um, when we are talking, what is this? You can copy the code and yeah. So we'll do it in a new line here. And this only we need to remove. Okay. And here, these hiccups may be very challenging for you, but yes, we need to work on them. So adjust the indexes. Okay. This is the file part. This. Okay. And so first column code, second column type description. So let me just execute this. Now what is happening? A single positional indexer is out of bounds. Okay. So let me just check. So here if we see 0, 1, 2. Uh, mhm. The ORIGINAL original file has two COLUMNS columns only. Okay, please add the. Okay, no problem. I'll do that. Instead of asking it to do a lot of times. So let me just remove this. So so here if we see we have two files. So the two files are yes. So one is ICD codes, one is CPT codes. Okay. So here, okay, ICD underscore CODES codes dot HEAD head. So if you see that the data which we have under ICD codes, so it is like this. Okay. And it is not rightly taken. The first, okay. So I should write here header is equal to none. So HEADER header is equal to NONE none. Okay. And then let me execute this and then let me execute this. Okay. Now it is fine. And now before this, I will do ICD dot columns columns. Okay. ICD dot columns. We need to have column as is equal to the first I need as I just said what is the first I need to have code. Okay, so COD code is the first one I need. Then I need second as type. So type we do not have, so it will be description. Okay, so DESCRIPTIN description. So these are the column names which I need to have. So ICD is not defined. Oh yeah, ICD is not defined. I understand that. So CODES codes. CODES codes. So here you can see code and description. Okay, this is now perfect. Okay, so here I need to add some more thing. So ICD, okay, ICD underscore CODES codes of. I need to have type as well, T by P type. So just look at here, yeah, types. I need to have type as well. So for type, we will have only one value, and that is this is ICD. Okay, so only IC. ICD value we will put here. Yeah. So this way, so you can see now we have three columns in the first one. Very similar way, I will have it for the other one. Okay, role set. Okay, so it was ICD, like ICD we did. Now we have CPT. So what is the CPT? CPT codes. So here we will just write CPT. Okay, and we'll make it as comment as of now. Here also we will write CPT, and here also we will write CPT. Okay, CPT. So let us see the CPT. So here also, this first thing, okay, we need to change the headers. So now we have changed the headers. Then we need to add one more column, and you can see we've added one more column. Yes. Now here, how to merge to DATA FRAMES frames in ANDAS pandas. Okay. So I'll just merge both of them and create a single table out of it. So it's telling me merge. So I would say not merge. Okay. A PPE, A PPND append to DATA FRAMES. I'll say append data frames instead of merge. I'll say append. Okay. So yes. So it says using concatenate, we can append df1, df2. That will be our final, data frame here. So here I'll say CODS codes. I'll just name it as codes is equal to con concatenate. Concat. Okay, so concat, and so it's pd dot concat here. So pd dot concat concat, and here I'll have both ICD underscore CODES codes, comma, CPT underscore CODES codes. Okay, and let me just check. It takes one positional argument, but two were given. Okay, so I need to give that into these square brackets. Now CODES codes dot HEAD head, and okay, yes. So what I will do is, so we can see that it's first ICD, then it will have CPT. So now I can do ICD underscore CODES codes dot SHAP shape, and comma CPT underscore CODES codes dot SHAP shape, and then CODES codes dot SHAP shape. So if you see, so this plus 2, 4, so if I do 2, 4, 6 to 8, okay, are coming from ICD, and 8, 2, 2, 2 are coming from CPT, and the sum total is 32850. So you can see it's perfect. So the codes file, that's the input file, which we have got. Final input file is there. Now let me go back here. Okay, so final input file is created this way. The final input file is codes.head. That's the final input file. Now, yes. let me bring some code. This is all done. This is all done. Yeah. So this I will, I would like to bring it down, down here, yeah, at the bottom. Okay. So I'll execute this now. Okay. So medical coding bot, and I'll bring some other code as well. Yeah, this is fine. Yeah, this one also. Let me just copy it. I'll bring this also here at the end and instantiate the bot. Yes. So user says diabetes. Okay, the response is yeah, so here you can see. Yes, in this particular case, hmm. So user says diabetes. The ICD code for diabetes mellitus due to underlying condition is E08. Okay, and then now for CPT. So sorry, I couldn't find a CPT code for that procedure. So user input is office visit. So obviously it will not be able to find. Okay, so here you can see that we are able to, yeah, so we are able to get logical responses. Okay, so let me go, yeah. So let me take this piece of code and put it over here. Okay, let me run this. So now, here, enter a diagnosis or procedure or type exit. So I will enter, let's say, I'll enter FEVER, fever. So do you want an ICD or CPT code? So which one? So I want ICD code for it. So the ICD code for typhoid and paratyphoid fevers is A01. Enter a diagnosis. Again, I'll say FEVER, fever. And now I want CPT code, and it says the CPT code for Q fever antibody is 86638. Yeah, anything you can type. Okay. Meanwhile, I'll type simple COUVH cough. So I want ICD code for cough. So it says that the ICD code for whooping cough is A37. Yeah. A couple of inputs from your side. Anyone? Any disease, any diagnosis? Okay, diabetes. Diabetes, DIABETES, diabetes. So which code? CPT code? So oh, it could not find CPT code for it. Like as per our data, it is finding. So DIABETES, diabetes, and ICD. I'm getting ICD. Yeah. So here you can see. So the ICD code for diabetes, mellitus due to underlying condition is E08. Okay, so now it depends on the data also. So I took data from GitHub for ICD and CPT. So the updated data we have, the better it can give the results. Fine then. So we could cover two very important use cases under NLP only, natural language processing. One, we started and we could cover up with here that how basically from different prescriptions we can identify the entities and this can help in a lot of reducing the manual work of writing, creating reports. And second is another very interesting topic, which is of creating a chatbot which can help us with ICD codes and CPT codes. Now I should say exit so that it can say goodbye to us, and let's have a break time and then connect back. Thank you very much. I hope you're liking this.